Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following exponential equations using the UK method. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, we have 3 to the power 2x minus 2 times 3 to the power x equals to 3. Using the exponential law that states that a to the power of x all raised to the power of y is equal to a to the power of x times y, which is xy, I'm going to separate each of the terms given in order to look for a common factor in each term. Before I do that, I'll start by moving all the terms to one side. I have 3 to the power of 2x minus 2 times 3 to the power of x minus 3. I'm bringing my plus 3 from the right hand side to my left hand side, and that is equal to 0. So applying the exponential law, I have 3 to the power of x all to the power of 2 minus 2 times 3 to the power of x minus 3 equals to 0. If you look at my new expansion, I have 3 to the power of x common. So therefore, I have let k equals 3 to the power of x. So every occurrence of 3 to the power of x, I'm going to replace that by k. So my new equation becomes k squared minus 2k minus 3 equals to 0. This looks more like a quadratic equation, which I can easily factorize. And factorizing, I have k minus 3 and k plus 1 as my factors. Therefore, k minus 3 equals to 0, or k plus 1 equals to 0. Either of the bracket, if 0, will make the equation equals to 0. For the first one, I have k equals to, moving my minus 3 to the other side, I have a k equals to plus 3. Remember, we've stated the value of k equals 3 to the power of x. So putting that back into my answer, I have 3 to the power of x equals to 3. And because the base are the same, this has an invisible power of 1. Therefore, I'm going to equate the powers, and x equals to 1. In the second part, I have k plus 1 equals to 0. Therefore, moving my plus 1 to the other side, it becomes k equals minus 1. Replacing k with 3 to the power of x, I have 3 to the power of x equals to minus 1. However, I can have 3 to the power of x being a negative number, so therefore, this is no solution. Let's look at the second example. In the second example, I have 16 to the power of x plus 8 times 4 to the power of x equals 48. Like I did earlier, I'm going to move all my terms to one side. So I have 16x plus 8 times 4 to the power x minus 48 equals to 0. Like I did applying the laws of exponents, I'm going to split each of the terms so that I can extract a common factor. 16 to the power of x, because I already have 4x here, I'm going to look for factors of 4x. So therefore, 16 to the power of x becomes 4 squared. 4 squared will give me 16. So I have 4x inside to the power of 2 plus 8 times 4 to the power of x minus 48 equals to 0. Now I have my k, which I'm going to say let k equals to 4 to the power of x, which is a common factor for 2 of the terms. Replacing that, I have k squared plus 8k minus 48 equals to 0. If I factorize, that's equal to 0, I will have k plus 12 and k minus 4. Therefore, my k plus 12 equals to 0, or k minus 4 equals to 0. And remember, we've stated already that the value of k is 4 to the power of x. I have k equals to minus 12. Therefore, 4 to the power of x, replacing my k, equals to minus 12. However, I can have 4 to the power of x having a negative number. So therefore, this is no solution. It's a positive number. On the other side, I have k equals 4, moving my 4. I have 4 to the power of x equals to 4, replacing my k. The base are the same. Therefore, I'm going to equate the powers. X equals to 1. Let's look at one more example using the k method. In my last example, I have 7 to the power of minus x plus 3 plus 7 to the power of 2 plus x equals 392. Like I did earlier, I'm going to start by separating the powers or moving all the terms to one side. I have 7 minus x plus 3 plus 7 to the power of 2 plus x minus 392 equals to 0. Making the exponent positive, I have 7 to the power of minus x here. And applying the exponential laws, if I have a to the power of minus 1, making the exponent positive, I have that as 1 over a. So therefore, doing the same thing, and also having exponents that have two terms, if I have a to the power of x times a to the power of y, that's the same as a to the power of x plus y. So for each term shown, before I make the exponent positive, I'm going to separate the exponent. So therefore this becomes 7 to the power of minus x times 7 to the power of 3 plus 7 to the power of 2 times 7 to the power of x minus 392 equals to 0. Now making the exponent positive, I have 7 to the power of 3 over 7 to the power of x plus 7 squared times 7x minus 392 equals to 0. Now we have a k because we have 7 to the power of x common. So therefore let k equals 7 to the power of x. Going back to our equation, we have 7 to the power of 3 over k plus 7 squared k, which is the same thing as 49. I'm going to leave it as 7 squared for now, times k minus 392 equals to 0. To make it a linear equation, I'm going to multiply each of the terms by k, and what that will give me is 7 cubed plus 7 squared times k squared minus 392k equals to 0. The reason why I multiplied through by k is because my LCD is k. I have that as over 1. So therefore, I'm multiplying by my LCD. If I simplify and collect like terms, I have 49k squared minus 392k plus 343 equals to 0. To make my equation easier, I can see that each of the term are multiples of 49. So I'm going to divide through by 49. My new equation becomes k squared minus 8k plus 7 equals to 0, because I already moved my terms to one side. And factorizing k squared minus 8k plus 7, I have k minus 7 and k minus 1 equals to 0. To simplify or solve for k, I have k minus 7 equals to 0, or k minus 1 equals to 0. Therefore, k equals to 7, or k equals to positive 1. Remember, we said let our k equals to 7 to the power of 3. So replacing our k, we have 7 to the power of 3 equals to 7. That's to the power, there's an invisible 1. I'm going to change that to 7 to the power of x, not 3. Therefore, because the base are the same, I'm going to equate the powers. So my x equals to 1. And on my right hand side, replacing my k with 7 to the power of x equals to 1. And we know that laws of exponent, any number raised to the power of 0 is the same as 1. So therefore, using the same base, I have 7x equals 7 to the power of 0, which is also equals to 1. The bases are the same. Therefore, the value of x is also 0. Thanks for watching. Bye.